Our last invited speaker is Dr. David Russo from the Volcani Institute here in Israel. David's PhD advisor was the late Eshel Bressler, who by that time started to collaborate with Gedeon on modeling flow and transport in the upper soil layer. These were first steps, and David has continued and expanded the research on these topics, both on theoretical aspects and applications to agriculture, watershed hydrology, and groundwater pollution. David has become the foremost researcher in these areas. He will present Gedeon's contribution to understanding water flow and solute transport in variably saturated soils.
Thank you, Gedeon, for inviting me. It's the second time that I present your contribution to unsaturated zone, and it's a privilege, and I'm very happy that I have this opportunity. Thank you. Okay, I will speak about Gedeon's contribution to understanding the flow and transport in the unsaturated zone. I want just to say something to my colleagues that Gedeon started with heterogeneity in the Veda zone before he wrote his very famous papers on transport in 1982 and go on with it in 1988. So another thing about the Veda zone that it's much more complicated than the groundwater and the aquifer, and everything that is started that goes to the groundwater, basically it started on the soil surface, goes through very complicated processes through what that goes into the groundwater goes through the Veda zone, and we have very complicated processes that occur in this very interesting part of the subsurface, and this is just a demonstration of what happened there. There are trees, vegetables, plants, root uptake, and all kinds of quite complicated processes. So we'll go on. I will speak about two things that Gedeon contributes. First of all, it's a direct contribution which is based on his collaboration with the late Eshel Bressler, which resulted in two pioneering articles. It's Dagan and Bressler from 1979, and then Bressler and Dagan 1979 as well. The starting point for this collaboration was the recognition that the special variation in soil properties is the bottleneck for application of physics-based deterministic models for solving problems of flow and transport on a realistic field scale. The Dagan and Bressler model is the one that was developed. The basic research question was how to develop a model for predicting solute transport while taking into account the special variations in the properties relevant to flow and transport. The approach developed by Gedeon and Eshel is based on combination of physics-based flow and transport model with stochastic methods that allow quantitative treatment of the uncertainty arising from the special variations in the soil properties. The result of this research, the model as known as Dagan and Bressler from 1979, is one of the first models of transport in the upper part of the heterogeneous unsaturated soil on the field scale. They used a number of simplifying assumptions, and the model gives quantitative expressions of the statistical moments of the transport variables, which are time and space dependent, of course. It depends on the statistical moments of the soil properties themselves. Also, Vladimir and Andrea and Aldo talk about Gedeon's desire to go to application. I mean, to develop theory, but then to go to application. And this is a very nice example of application, which is agricultural oriented. It's leaching of saline soils. So in this figure, we can see the probability that the root zone concentration will not exceed a given level of C star, for example, after a given time. In this case, steady state leaching of sandy soil, which is on the left-hand side, and clayey soil on the right-hand side. Under the ergodic hypothesis, these probabilities represent the fraction of the field area for which C will exceed C star and the total field area. And for example, if we took this figure, we can see that if we consider for the reference C star of 0.8 for the sandy soil, after 4 hours of continuous leaching, for half of the field area, 80% of the initial salt mass will be leached. On the other hand, for the clayey soil, this will occur after 140 hours of continuous leaching. So this is a very nice application of the model developed by Gedeon and Eshel. A considerable number of subsequent studies by Gedeon and Eshel relied on this model. Furthermore, other researchers, for example, Vistuni and Cvetkovic, extended the 1979 model, and they wrote few articles based on this approach. An expression of the influence of the 1970, excuse me? Oh, an expression of the influence of the 1970 paper on the research in the field of flow and transport in soil is given by extent of his citation. The citation index showed that until 2022, this article was cited almost 300 times, which is a nice figure. This is conclude the direct contribution of Gedeon to unsaturated flow, but there is a huge influence of Gedeon work in groundwater flow on which influence the understanding of flow and transport in the Veda zone. Okay. Okay. So the indirect contribution of Gedeon is basically based on a relatively simplified two-dimensional vertical simulation of solute transport that I did back in 1991. And I showed Gedeon the results and the fantastic agreement between special moments analysis of the results of the simulation, which were for conditions of non-steady flow in an unsaturated flow, with Gedeon predictions based on steady state flow, but in a Lagrangian approach, of course, give us some idea that maybe we can go on with this approach, even though it was developed for relatively small heterogeneity and steady state, etc., what my colleagues said earlier. So based on the detailed analysis of the results of this simulation, we wrote together a paper which concluded that despite the complexity of the transient unsaturated flow as compared to saturated steady state flow, the former can be analyzed in a similar manner. This conclusion led to a large number of articles, starting from 1992 up to 2006, focusing on 3D analysis of flow and transport in spatially heterogeneous unsaturated soils, based on the stochastic Lagrangian theory of transport in steady state saturated flow, cited in these articles by Gedeon. So an example, which is an extension of the Lagrangian approach to combined unsaturated, saturated flow, is given by a study that I conducted back in 2009 with Aldo. This is a scheme of the combined flow system. You can see that we have an entry zone at the soil surface. Here is the groundwater, and we have here a control plane, horizontal control plane, and a second horizontal plane in the groundwater. And we analyzed this numerically and analytically based again on the Lagrangian approach developed by Gedeon. Holy Caroni. Okay, the results are given here, the first order analysis, and I want just to say one word about the limitation of the first order approximation. The log K the variance of log K in this case is about unity, but the variance of the unsaturated log K can go up to 4, 5, 6, and still the agreement between the first order analysis and the numerical analysis and the numerical simulations is, I think, very good, more than that. And both approaches clearly show that the enhanced spreading of the expected tracer BTC in the groundwater as the enhanced spreading of the expected tracer BTC in the groundwater as the mean saturation of the Vaduz zone decreases. The latter corresponded, of course, to a decrease of the recharge on the soil surface. So this is basically, I think, summarize application, indirect application and the contribution of Gedeon to understanding and predicting flow and transport in the Vaduz zone, and more than that, in a combined Vaduz zone groundwater system. I want now to conclude. Yeah. I want to summarize that Gedeon's contribution to understanding flow and transport in realistic soil is significant and manifested by hundreds of citations of his predictions based on his theoretical studies in groundwater flow and transport. The latter has a significant role in the recognition of Gedeon as a highly cited researcher in two categories: environment, ecology, and engineering by the Institute of Scientific Information, the ICI. Thank you very much, Gedeon, again, and thank the audience.